Mars is often described as humanity's next home, a planet waiting for us, a backup world. But consider a simple thought experiment. Imagine a human standing on the surface of Mars. No dramatic accidents, no explosions, no sudden failures, just a person standing there. Within minutes, their body would begin to fail, not because of one critical mistake, but because Mars is quietly hostile in ways that don't feel cinematic. And that's exactly why we misunderstand it. This is not a video about why Mars is impossible. It's about why the Mars we imagine doesn't exist. Mars feels close to us. Its day is almost the same length as Earth's. It has seasons, it has polar ice caps. From orbit, it even looks familiar. For decades, this familiarity shaped how we talk about Mars. Not as an alien world, but as an unfinished Earth, a place that's almost ready. And that almost is dangerous, because familiarity creates expectations, and expectations shape belief. Mars feels like a planet we could adapt to, and because of that, we rarely ask a more important question. What does it actually mean for a planet to be livable? Our idea of Mars was never built by physics alone. It was built by stories. Science fiction didn't invent the idea of Mars as a second home, but it reinforced it generation after generation. In these images, Mars is harsh, but manageable, hostile, but conquerable. Technology fills the gaps. Human ingenuity smooths the edges. What's rarely shown is something much quieter. The daily invisible pressure a planet puts on the human body. The kind of pressure no heroic moment can overcome. Mars became a symbol long before it became a destination. And once a planet becomes a symbol, we stop seeing it clearly. Mars is not hostile in the way movies teach us to recognize. There are no constant catastrophes, no dramatic countdowns. Instead, Mars is hostile by subtraction. Too little gravity, too little atmosphere, too little protection. Each difference seems manageable on its own. Together, they form a system that quietly works against life. Mars is not a broken Earth. It's a different category of world entirely. When we ask whether Mars is livable, we usually mean something very specific. Can we build habitats there? Can we survive for a while? But that's the wrong question, because humans don't live on technology. They live inside environments. A livable planet isn't one you can stand on. It's one that works with you, even when nothing is working. Gravity is not just a force. It's a long-term instruction manual for life. Every cell in your body developed under a very specific pull. On Mars, gravity is only about a third of Earth's. At first, this sounds like freedom. But biology doesn't interpret this as freedom. It interprets it as a problem. Bones weaken, muscles atrophy, systems adapt in ways we can't fully reverse. Gravity isn't optional, it's structural. When people talk about atmosphere, they usually think about breathing. But atmosphere does much more than that. It shields us. It spreads heat. It softens extremes. Mars technically has an atmosphere, but it's thin enough that the planet behaves like it doesn't. On Earth, atmosphere is a buffer. On Mars, it's a suggestion. Earth has another system we rarely think about, because we never had to: its magnetic field. Mars lost this shield long ago. Without it, the planet is exposed constantly, not catastrophically, just enough, every day, to matter. Each of these problems is often discussed in isolation. But planets don't work in parts. They work as systems. Mars doesn't fail because of one flaw. It fails to support life because its systems don't reinforce each other. When a planet doesn't provide what humans need, the solution seems obvious. We build it. Sealed habitats, artificial environments. On paper, this works. But Mars changes the meaning of the word inside. There's a difference between surviving in a system and living in one. A space station is designed for months, not generations. Mars removes external support. Every seal matters. Every filter matters. Failure isn't dramatic. It's constant. Technology doesn't usually fail suddenly. It degrades. Mars accelerates that process. Dust covers everything. It's abrasive, persistent. On Earth, maintenance is inconvenient. On Mars, it's existential. There is also pressure technology can't remove. Psychological confinement. No horizons. No weather you can feel. No spontaneous space. On Mars, you don't step outside to clear your head. You step outside to die. Scaling doesn't solve this. It amplifies it. A city on Earth survives because failure is local. A settlement on Mars would be globally coupled. At that point, you're not building a society. You're maintaining a life support machine with people inside it. Chapter 4. Terraforming, the popular illusion. When the limits of habitats become clear, the idea shifts. Terraforming. If Mars won't adapt to us, we'll adapt Mars. It sounds inevitable, visionary. Terraforming promises a future where we don't have to change. Most ideas begin with the atmosphere, release trapped gases, increase pressure. But even if all accessible CO2 were released, the atmosphere would remain extremely thin, not enough to change what the planet does. Mars leaks constantly. Let's assume we warm Mars. The problem becomes retention. Without a magnetic field, heat and atmosphere escape. Terraforming becomes maintenance, not a transformation, but a permanent struggle against physics. Mars lacks something no technology can easily replace: an active core. Earth's core powers stability, recycling, protection. Mars doesn't recycle. What it loses permanently. Restarting that system is not engineering, it's planetary surgery. Terraforming also assumes time, hundreds or thousands of years, and uninterrupted stability across generations. History suggests otherwise. Terraforming persists because it offers reassurance, a promise that no matter what happens, we can build another Earth. But promises don't obey physics. Mars is not unfinished. It is finished. Despite all this, belief persists, because Mars is no longer just a planet. It's an idea, and ideas survive because they're useful. Mars offers psychological relief, a backup plan. It absorbs our anxiety, not because it can save us, but because it allows us to imagine survival without responsibility. Technological optimism reinforces this. Technology solves problems, but it doesn't replace foundations. We confuse tools with environments, solutions with systems. Mars also fits an old story: the frontier. But frontiers on Earth worked because the planet beneath them was alive. Mars is not a frontier, yet the narrative persists because it tells us who we want to be. The danger isn't believing in Mars. The danger is using Mars to avoid fully confronting Earth. If Mars isn't a home, why go there at all? Because Mars is a record, a preserved example of what happens when planetary systems fade. It's not a destination, it's a warning. Mars is frozen in time. Its surface preserves ancient history. Earth erases its past. Mars keeps it. By studying Mars, we study a path Earth never took. Mars helps us understand habitability, not where life exists, but why it lasts. Small early differences produce radically different outcomes. Mars didn't fail catastrophically. It drifted. Mars is not our future. It is our mirror. A reminder that planets don't need to explode to become uninhabitable. They just need to stop protecting life. Mars doesn't need cities. It needs observers, not settlers, but students. Mars doesn't reject us. It doesn't care. The danger was never that Mars is hostile. The danger was believing it was waiting. For a long time, we treated Mars as a promise, a reason to believe survival is guaranteed. But that belief shifts responsibility. Mars becomes an excuse to delay hard choices. Earth is not replaceable, not because it's perfect, but because it's alive. Mars shows us what happens when planetary systems fade. That is its real value. Mars will still be there, cold, silent, unchanged. The question is not whether we can live there. The question is whether we can learn to keep living here.